Good morning. Happy Tuesday. Today is day 130. This is the video recap for day 130, and we're going to be focusing on how when we work with linear systems, how we can create graphs for those systems, and how the graphs can help us find common solutions to those linear systems. For part A today, you first should have analyzed the graph as they give it here. We see an equation in the green box, y equals 1/2 x plus 2. That's attached to this green line shown on the graph. And then we also see a red equation, y equals 5 minus x, and that's attached to a red line that's not created or graphed for us yet. For part 1, they said use the graph to identify 3 different solutions to y equals 1/2 x plus 2. And we see the graph, or the equation graphed out here for y equals 1/2 x plus 2. They asked us to write your solutions, the solutions to this equation, as ordered pairs, which just means x's value, comma, y's value, and we put that inside parentheses. The key to understand for part 1 is that if we already have the graph for this linear equation, the line, each point on this green line represents a different solution. So if I zoom in a little bit and we take a look at this graph, we see that the green line, focused in on this point right here, the green line passes right through this point. The y-intercept is 0 for x right in the middle of the graph and 2 for y. So the first solution we could put is 0 for x and 2 for y. If I plug a 0 into this equation, 1/2 times 0 would just become 0, and 0 plus 2 would leave us with a value of 2 for y. But the way I found that is, since we already have the graph, just grab a point on the graph. Any other point on the graph, right here, 2 for x and 3 for y could be another solution. 2 for x, 1/2 of 2 is 1, 1 plus 2 makes 3 for y. But again, I found that x is 2, y is 3 point on the green line. We could even take a point way out here. When x is at -8 on this green line, y is at -2. So we could even say, if we wanted to get challenging, when x is -8, y is -2. For the second part, you were asked to create a graph for the equation y equals 5 minus x. We see the red equation is not graphed out yet. 5 minus x, they haven't created the line. And the way we're going to create a graph for an equation, or create the line for that equation, is to first identify 3 different solutions. Here, the easiest thing I think to do to find solutions to this equation is to plug in numbers. If I plug in a 0 for x, I make x into 0. The equation says y will equal 5 minus 0, or y would have to be 5. I could also go ahead and say, instead of x is 0, x could be 2. 5 minus 2 would leave us with a 3 for y. And then I could even say x is equal to 4. If x is equal to 4, 5 minus 4 leaves a 1 left over for y. So at the end of the day, these are my different solutions. You could have come up with different ones, but just plug in a number for x and see what this equation says y has to be. We have 3 different solutions. 0, 5, 2, 3, and then 4 and 1. In the interest of going quickly, I'm just plotting those 3 points. 0 and 5 is the first point, so that's right there. The other 2 points, 2 and 3, and then 4 and 1 are the other 2 points we'll graph here. So 2 for x and 3 for y. And the last one, 4 for x and 1 for y is right there. And we see if we click on this red line, we can grab the blue dots at the end, stretch this line, and can even continue through that way. There's our equation. If we really want to label it, we could put that there. You could even extend the line in both directions through all those points. So that's part 2. That graphs your red equation. And the whole big goal today, if we focused on objective 3, was to create a graph for our linear systems. And the reason we're creating these graphs is to find if they share any solutions, if they have any common solutions. You all should be able to find the common solution. If this is all the solutions to the green equation, this is all the solutions to the red, where they cross. When x is 2 and y is 3, we saw that solution showed up for both red and green, so that's the common solution. Part B, and we're going to run through part B pretty quickly in the interest of time. Part B, we show you a second method to graph this purple equation. You could plug in 0 and 1 and find solutions, but the easiest thing if it's in y equals form is to identify the y-intercept. That's the plus b here of 0 and 4. The slope is -2. And that slope right here, we see the slope is the mx negative 2 is times with x, so we know the y loses 2 every time the x gains 1. When you graph that out, the y-intercept is the first point we should always plot with this method, so 0 and 4. And then the slope of negative 2 over 1 says every time we go down by 2, every time y loses 2, that's because x just gained 1, or we move right by 1 every time we go down by 2. And then that can help us figure out where the common solution is. Sorry for the delay there. So down by 2, right by 1, down by 2, right by 1. We see that purple line goes through these 3 dots. Not perfectly, but here's our common solution when x is 3 and when y is negative 2.